7.3, solve linear systems. By adding or subtracting. Now, I'm going to tell you that I personally think that the method that I'm going to show you is easier so that you just don't get confused, and it'll kind of be a nice little like limbo to get us into the stuff for tomorrow that gets a little bit more difficult. But you'll see what I mean in just a second. So, solving by elimination. The first thing that we're going to do is we're going to, it's going to say add or subtract the equations to eliminate one variable. But what I would say with that is I might be showing you a different method where we actually multiply by -1 if they're not already opposite, to make it easier, and it'll like help as we transition into the next section as well. So then step 2, solve the resulting equation for the other variable. And then finally substitute into either of the original equations to solve for the other variable. All right, so the first ones that we're going to do say to solve using addition, or well, like the addition method, which basically just means that we are going to have opposite signs. So you'll see what I mean in just a second, but we're just going to jump in. It's the easiest way to do these. So number 4, we have 9x plus y equals 2, and we have -4x minus y equals -17. So we're going to stack these up just like we would if I was going to tell you to add something like 33 plus, for Drew, 67. And we're going to still basically be like adding in its own individual column. Now, something that carries, that doesn't work the same way here, but we're stacking it up so that it looks like this, and I'll be adding like 2 and -17 and so on and so forth. Okay? So, I like to just draw a line under here. You don't have to draw the line, but that way it shows you what you're doing. And so in here, we have a positive y and a negative y. So those are going to cancel with each other. So that means that I'm good to go. So that's my first step. Again, trying to like lead into the stuff that we'll be doing tomorrow. If I don't have things that have the same number opposite sign, then I have to do something to the equation. So that's my first thing I'm looking for. So I can see that the y's are going to cancel. So I've got 9x minus 4x. So that's 5x. Y minus y, that just goes away. And then equals to -17 is -15. And then divide by 5. So x equals -3. So that's x. Now, I take that x value, and I can choose either of these original equations to plug it into. So do you want to use the first one or the second one?
First one. Second one.
So I would say, just so that you can see kind of my process, it really doesn't matter. You're going to get the same answer either way, but I would suggest the first one because I'm plugging in for x, but look, y is already by itself. It just has a +1 in front of it, so I don't have to do anything. If I choose this one, I'm going to have to divide by a negative ultimately, right, because I got to get it by itself. So I've got 9 times -3 plus y equals 2. So 9 times -3 is -27 plus y equals 2. Add this 29 over, so I get y, or add this 27 over, so I get 29. 2 plus 27 is 29, and then we write our answer the same way we've been writing it, -3, 29. And again, you could plug that into either of those original equations to check, just like you've been able to check all the other ones. Questions on that? All right. 6. 3x minus y equals 30, and -3x plus 7y equals 6. So again, I'm looking to see, is there something that already has same number, opposite sign, so that I can just proceed with just combining them? Well, I've got a positive 3x and a negative 3x, so those things cancel, so that means that I'm good to go. I don't have to do anything. So that goes away. And then I've got -y plus 7y, so that's 6y equals 30 plus 6 is 36. Divide by 6, so y equals 6. Now I can take that and plug it into either of the original ones, doesn't matter. I would probably recommend, if it was me, the top one. Any idea why I would maybe choose the top one? Yeah, there's nothing that I have to multiply that by then other than just like the negative sign, right? So down here, if I plug it in, I've got to multiply 7 times 6. Up here, I can just plug it in. So, but again, you can do it in either one. That's just my process. So I've got 3x minus 6 equals 30. I'm going to add this 6 over here. So I've got 3x equals 36. Divide by 3, so x equals 12. So my answer is, now notice, I was about to write it backwards. Make sure you put it in the correct order, x then y, so it's 12, 6. All right, I'm going to have you try this next one by yourself. I know we've only done 2, but these are the easy ones. I feel like you can probably handle this one, so try this one on your own. If you don't understand, we're still going to do more. 3x minus 5y equals -7, and -4x plus 5y equals 14. So I'll leave the other one up there for reference, so take a second and try that one and see if you can get to the right answer on it. And the other thing I didn't say, but if you're going to check it, I would suggest you check it in the equation that you didn't use to solve for the second variable, just to make sure that it works in that one, but just my 2 cents on the topic.
Guess what you think? My cat attacked me last night.
Why?
Because I was walking out of my mom's room because I stole him so he could sleep with me. And I was walking out the door and I was shutting it behind me, and his tail got stuck. So he freaked out. So he scratched me right here, and then he scratched me right here, and it really hurt. And my face was bleeding.
That's not good. All right, do we have an answer?
-1, 2.
Y'all agree with them?
Yeah, because I'm smart like that. Yeah.
Yep. So the y's canceled, so we had -7x equals 7. Divide by -7, so we get x is -1. I chose to plug it into the bottom one because there were less negative signs, but it really didn't matter. So then I got that's +4 plus 5y equals 14. Subtract 4, 5y equals 10. Divide by 5, y equals 2. Questions on that one? All I'm going to fill up my water really quick. And then I'll come back and we'll keep going.
No.
Okay. So now we're going to move on to the ones that they classify as subtraction. Anyways, so I'm going to show you what that means. So number 10, we've got x minus y equals negative 4 and x plus 3y equals positive 4. So my first thing is always check and see, do I have something that has same number, opposite signs? Do I have that?
Yeah.
White.
Same number, opposite signs?
No.
It's got to be in front of a variable. I've got to get one of the variables by itself.
X and X.
They have opposite signs?
Oh.
What do we do?
So this would be where they would classify that you need to do subtractions. I'm going to kind of show you two different ways that you can set it up. You can choose your favorite one to do it. So in the other one, we were technically adding, but we had things with opposite signs, so you could argue that was subtracting, but anyways. So down here, I can take this whole thing and I can subtract each thing, but if I do that, then I have to remember to sit here and subtract. So then I would have, okay, x minus x is 0. Okay, that goes away. Negative y minus 3y is negative 4y. And then negative 4 minus 4 is negative 8. And I can do it that way. But I've got to sit here and I've got to remember to subtract every single time. And oftentimes after this first one, people don't put the parentheses and they only subtract x and then they get it wrong because they didn't change the signs on these. So you can do it that way. That's totally fine. The other way that will lead into what we're going to do tomorrow is they're going to give us stuff where the numbers aren't the same. So right now I have still in front of my x's, they both have a positive 1, right? Well, we're going to end up with stuff like, ignore the x's for right now, like this, where they don't have the same number, and I've got to do something to get it to where I can cancel one of them. So I prefer to use this method. This is like the book method. This is my method over here. So I keep the top equation in this particular situation. So I have x minus y equals negative 4. Then, instead of me having to sit here and remember to go x minus x, negative y minus 3y, I just distribute this negative to everything. So that would give me a negative x minus 3y equals negative 4, and then I add. So then you're using the step from the first part. Either way, you're going to get the same answer because the same thing is happening, but I just think it's easier because I tend to forget over here to like sit there and subtract everything if I do it that way. I don't care. I usually show it this way, but I'm just letting you know the book's going to go about it that way. So we get negative 4y equals negative 8. Divide by negative 4. Y equals 2. And then when you do this, you can plug it into this manipulated equation if you want, or you can plug it into the original. You're going to get the same answer either way. That's going to be more important when we get into like the sections where we're multiplying stuff. I would strongly encourage you use the original equation because the math is easier. Not because it's going to give you the wrong answer, but just because it's easier. But I'm going to use the top equation because the math looks like it's going to be easier on that one in this particular case. So I've got x minus 2 equals negative 4. I'm going to add the 2, so x equals negative 2. So my answer is negative 2, 2.
Yay! Is this all it's going to be?
For today, that's basically it. So, which method do y'all like better?
That one on the red.
This one? The red one? Okay. Good choice.
Can we just like not do homework since it's so easy?
No. 12. 6x plus y equals negative 10, and 5x plus y equals negative 10. All right, so do I have variables that have the same number opposite sign in front of them?
No.
But do I at least have ones that have the same number?
Yeah.
Okay, so that's the next thing that we're going to be looking at again, kind of previewing tomorrow for you, or most likely tomorrow. I think we're going to do that tomorrow. Anyways, is I'm going to look for at least something that has the same number if I can. If they don't have it, then that's going to be another whole process. But anyways, so again, you can do either equation, multiplying it by the negative. I could do the top equation if I was so inclined. I usually just do the bottom one when I'm just changing the sign. Because then I don't know, it just makes things look pretty to me, but up to you. So I'm going to multiply this entire bottom equation by negative 1, or a negative sign. So I'm going to copy down the top one. So I've got 6x plus y equals negative 10. Now I'm going to distribute this negative 1. Thing is blinking. So I've got negative 5x minus y equals positive 10. So again, remember, it goes to every single thing. And now I'm going to combine the stuff together. So I've got 6x minus 5x. So that's just x. Y minus y, that's gone. Negative 10 plus 10. Well, that's just 0, so that was easy. So then you want to use the top equation or the bottom equation? So I'm going to plug it into the top. I've got 6 times 0 plus y equals negative 10. That goes away, so y equals negative 10. So I've got 0, negative 10. You see why I like this method better than the one we've done the last 2 days. All right, try this one on your own. We're going to do one more after this one, but I want you to try this one on your own. 4x minus 9y equals negative 21, and 4x plus 3y equals negative 9. So notice the variable isn't completely by itself in these ones, right? There's a number in front of all the variables, but the process works the same way, okay? So take a minute and try that one. We have an answer?
Negative 3, 1.
Do we agree?
Yes, because I'm smart. 3 for 3, let's go.
All right, so we had the x's had the same number, but they did not have opposite signs, so I multiplied the bottom one by the negative. I started to mix y'all up, and I was going to do the top one, but I just stuck to the bottom one. So anyway, so I changed the signs on that stuff, and I got negative 12y equals negative 12, and then divide by negative 12, so y equals 1. Now notice, I used the bottom equation, but I used the original because I wanted you to see that it worked. So I had 4x plus 3 times 1 equals negative 9. And then I basically subtracted 3, so I got negative 12. Divide by 4, so I got negative 3. Okay, and you get the same thing if you use the manipulated one. Or you could have used the top one, which is, I'm guessing, what y'all probably did was use the top one. But
I used the top one. I used the bottom.
did you use the original bottom or the manipulated bottom?
Original.
All right, questions on that? All right, so the only reason I'm doing one more is because sometimes they don't make things look quite as nice for us. So 18, I've got 2x minus y equals negative 11, and I've got y equals negative 2x minus 13. Now, if this was a problem in a section that says solve using any method, because I will most likely, at least by the test, give you some that you have to use a specific method. I'll say you have to solve by graphing, solve by substitution, or solve by elimination. Or I will tell you to solve using any method. If I tell you to solve using any method, I would use substitution on this one. Why?
Because you have to change it to
Yeah, because y is already by itself. I can take that negative 2x minus 13 and plug it in. But this section says that I have to do elimination. So if it tells me I have to use elimination, then I've got to get it set up so that I have all my variables on one side, essentially in standard form, if you remember standard form from way back when we were graphing. So that means I need to add this 2x over to this side. So I have the top equation, 2x minus y equals negative 11. I'm adding the 2x from on the bottom equation to the other side, so I'd have 2x plus y equals negative 13. Now, once it's in this form, I say, do I have something with the same number, opposite signs? Taylor says yes. Which variable is it? Those have the same number, but do they have opposite signs?
Y.
The y's have opposite signs. So that means I don't need to do anything. I can just add down like we did in the first problems that we did. So I've got 2x and 2x is 4x. Negative y and positive y cancel. That's why this is called elimination. Hopefully y'all figured that out by now. Equals negative 24. Divide by 4. X equals negative 6. Should I accidentally open the door? How do you accidentally open a door? Okay. Now, at this point, then, I would choose the bottom original equation. Why do you think I might do that?
Because it's like y.
Yeah, no, exactly. It's y equals, and I need to solve for y, so I might as well take the easy road. You can use the manipulated equation if you want, or you can use the one that's on top and have to do a little bit more work, but, you know, I like the easy way out, so I'm going to choose the bottom one. So I've got y equals negative 2 times negative 6 minus 13. So that is positive 12 minus 13. So y is negative 1. So my answer is negative 6, negative 1. Questions on any of these? All right, problems.
1, 2, and 3.
5, 7, 11, 13, 17, and 19. Now, I did not do one like 17. Sometimes what they do instead is they give you like 3x plus 2y equals 7, and then they might do something like negative 5y minus 3x equals 2, or something like that. That just means you need to swap the x and the y down here and rewrite this bottom equation as negative 3x minus 5y so that it's in order. Okay? So then I would just scratch that one out and just use this one. You're not changing the signs of it or anything. It's literally just swapping the places of those two things. So that's one like 17. 19 is similar to the one we just did at the end. So just for the heads up for y'all, I'm going to plan to go ahead and do 7.4. I knew I said it kind of depended on if it was going to snow or not, but I would rather just go ahead and finish up this stuff that all goes together tomorrow and then quiz on 7.1 to 7.4, meaning that then we'll have a quiz on 7.5 and 7.6 and eventually whenever that happens. So if we're in school on Monday, the quiz will be on Tuesday. If we're not in school on Monday, the quiz will be on Wednesday. Basically, whenever we come back, we're going to have a review day, and then we'll have a day to work. Now, I will tell you, you'll need to take your books home this weekend because I will send you the quiz review so you could work on it at home as part of your virtual work. I may have a worksheet with a few different types of problems where you're sitting there and determining which method you should use as well. But we'll just see where we get tomorrow, and we'll go from there on that. And hopefully by tomorrow at this time, we'll have a better idea of if we're getting snow and how much. So, but just to give you a heads up, tentatively plan for a quiz on 7.1 to 7.4 on Tuesday. Okay? Assuming no snow happens. What? This is 7.3. But 7.4 basically is the same stuff as this. It's just multiplying by a number instead of just a negative sign. So, it's really not that much harder, but yes, Taylor. Yes.